All right, here we want to look at some examples dealing with finding limits and particularly one-sided limits here. The first function we have is calculating the limit of 2 over x plus 2 as x approaches 2, and again this little negative sign up here that says we're approaching 2 from the left. Well, probably the easiest way with calculating a one-sided limit is sometimes to actually just simply look at the graph of your function. So here we have the graph of 2 over x plus 2. And again, we know there's nothing to cancel out. So clearly at x is a negative 2, there is a discontinuity. Well, if we look closely here, there's a discontinuity at negative 2. And be very careful with this problem. It says, what's the limit as x approaches 2 from the left? Well, we're approaching 2 from the left, and 2 is located over here. This is a positive 2, and we're approaching 2 from the left-hand side. So that means we're approaching from this direction. From the left, we're approaching 2. And if you notice, the function is actually defined at 2. So we could actually use direct substitution and get 2 over 2 plus 2, which would be 2 over 4, which equals 1/2. So therefore, the limit here is 1/2. So again, we're approaching positive 2 from the left-hand side. Now, really for this example, it didn't make a difference. If we were to approach 2 from the right-hand side, we would still be approaching 1/2. We're still approaching the same value here. Okay, so be careful. The negative sign says we're approaching 2, but this is a positive 2, so here the limit is 1/2. Now you may ask, what would happen if we were approaching negative 2? If the problem says what's happening is if we approach negative 2 from the left, well here there's a vertical asymptote at negative 2, and if we were approaching negative 2 from the left, what's happening to your graph? If we approach negative 2 from the left, your graph is going down. Again, there's a split, so therefore your limit does not exist if we were approaching the negative 2. All right, the second example involves absolute value. We have the limit of absolute value of x minus 5 divided by x minus 5, and we're looking at as x approaches 5 from the right. So if we go over here and look at this graph, we're approaching 5 from the right. So graphically, we could look at this and say, well, if we're approaching this from the right-hand side, clearly this top line here is constantly at positive 1. So the answer should clearly be 1. So that is our limit. Now, kind of algebraically, how could we figure this out? Well, if we're approaching 5 from the right, that means we're picking values that are greater than 5, getting closer. Now, for example, if I was to pick the number 6, that's to the right of 5. If I was to use 6, we would have 6 minus 5 absolute value over 6 minus 5. Well, 6 minus 5 is 1. Absolute value is 1, so you'd have 1 over 1, and then clearly the limit would be equal to 1. Now the second example I have at the bottom is the same function, but we're looking at approaching 5 from the left. So we're approaching 5 from the left-hand side. What's happening to the limit? Well, graphically we can tell that as we approach 5 from the left, our y value is constantly equal to a negative 1. So that's going to be our limit. Well, algebraically, if we were to pick values, for example here, less than 5, as we get closer, we could think of picking a 4, and if we plug in a 4, we would have absolute value 4 minus 5 over 4 minus 5. And on top, 4 minus 5 is a negative 1, but the absolute value would make it positive 1, and then on the bottom you get 4 minus 5 as a negative 1, and 1 over negative 1 shows you that your limit would be a negative 1. Now, what happens if I introduce a fourth problem? What's the limit of this function as x approaches 5? Well, there's nothing up here to tell us to the left or the right, so that tells us this is a two-sided limit. So that means we're looking from the left and the right, and we know that from the left we have a -1, from the right we have a +1, so that means for the two-sided limit, the limit simply does not exist, and that's because we're approaching two different values. Okay, so if you're looking for a one-sided limit, from the left-hand side, it's a -1. From the right-hand side, it's a +1. But if we look at the limit as x simply approaches 5 from both directions, it does not exist because we're approaching two different numbers.